Is square and rectangle similar? So how we will check the similarity of two polygons? By checking the corresponding angles as well as by checking the ratio of the corresponding sides. Now let us take, according to this question, square and rectangle. One square with a side 3 centimeters or 3 units, and one rectangle, the length as 4 units and the breadth as 2 units. Now we need to check whether this square as well as rectangle both are similar or not. So first we need to check the corresponding angles. If the corresponding angles are equal, we will go with the ratio, corresponding sides ratio. So first check angles. For square, all the angles are 90 degrees. In rectangle also, all the angles are 90 degrees. So here corresponding angles are equal. Then corresponding angles are equal. Now I need to go with the corresponding sides ratio. Lower side by lower side 3/4. Right side by right side 3/2. We know very well that these two are not at all equal. So I can conclude one thing here, that is corresponding sides ratio is not equal. So square and rectangle are not similar figures. In the figure we have one triangle ABC and one line DE in the middle, and some measurements are also given. Then he is asking to check whether DE line is parallel to BC or not. So this is DE and this is BC. Now we need to check whether these two are parallel or not. So for that we are going to use the basic proportionality theorem concept. So that is AD divided by DB equals to AE by EC. If these two ratios are equal to each other, then we can conclude that this DE line is parallel to BC line. So let us check whether these ratios are equal or not equal. AD is 2 by DB is 4. So if we simplify this one, we will get it as 1/2. Next, AE is 6 by EC is 12. If we simplify this further, we will get the answer as 1/2. So here we can conclude that 1/2 is equals to 1/2. So here AD by DB value is exactly equals to AE by EC value. So we can conclude that this DE line and BC line both are parallel to each other. Next, in the given triangle ABC, two lines, that is DE line and BC line, are parallel to each other. These arrows indicates parallel lines. Then he is asking to find out that missing alphabet, that is X value. So if these two lines are parallel to each other, then we can apply the BPT easily. So that is AD by DB equals to AE by EC. So let us substitute the numbers now. AD value we have is X by DB 4 equals to AE 3 by EC 12. Let's do cross multiplication. X into 12 equals to 3 into 4. X into 12 equals to 3 4s are 12. Now we need to find out the X value. So take 12 to the right side. So that will become X is equals to 12 by 12. So 12 by 12 is nothing but 1. So X value is 1. In a triangle ABC, DE is parallel to BC, then find the X value. So here DE and BC both are parallel lines, so we can apply the BPT here, the same, that is AD by DB equals to AE by EC. So here what is AD? That is 2x by DB x plus 1 equals to AE x plus 2 by EC 3x. So we need to do cross multiplication of this. Let us simplify this further. 2x into 3x equals to x plus 2 into x plus 1. 2x into 3x, 6x square equals to x plus 2 into x plus 1, x into x, x square, x into 1x plus 2 into x, 2x plus 2 into 1, 2. So now everything I will take to the left side completely. So we will get 6x square as it is, plus x square if I take to the left side, minus x square, plus x become minus x, plus 2x become minus 2x, plus 2 become minus 2, then equals to 0. Now let us simplify this further. 6x square minus x square, 5x square, minus x minus 2x minus 3x minus 2 equals to 0. Now by splitting the middle term into two terms, and we need to find out the x value here. So let us check that one. Here 2 5s are 10. So 5x square as it is. This middle term I am writing it as minus 5x plus 2x minus 2 equals to 0. Now from the first and second term we can take out 5x common. So if I take out 5x common, then remains with x minus 1. Here plus 2 common, x minus 1 equals to 0. Then finally we remains with 5x plus 2 into x minus 1 equals to 0. Now making the factors equals to 0, that is 5x plus 2 equals to 0. Then take plus 2 to the right side, then we will get 5x is equals to minus 2. Then x is equals to minus 2 by 5. The same way x minus 1 also make it equals to 0. Then minus 1 if we take another side, it will become plus 1. So x is equals to plus 1. Next, we have one triangle ABC. And in this ABC triangle, this DF line and AE line both are parallel to each other. Next, DE line and AC line both are parallel to each other. Then he is asking to prove that BF by FE equals to BE by EC. So let us take this clearly once. So what I am going to do is whatever the parallel lines we have, that parallel lines only I am going to vary. So for that I am removing the unnecessary lines. Now first I am taking these parallel lines, that is this straight parallel line DF and AE. First I am going to worry about only these two parallel lines, that is DF and AE. So not to have any confusion, remaining two lines I am removing. Later I will add it again. That's it. Now if we observe this clearly, we have this triangle ABE triangle, right? So ABE triangle we have. Now for this ABE triangle, if we apply the basic proportionality theorem, what it will become then? BF by FE equals to BD by DA. That is nothing but this upper one by lower one equals to upper one by lower one. This is completed. Okay, now let us move to the second parallel lines. Let us check from that also what we will get. So what is that second parallel line? Join this one, then join this one. This parallel to this one, right? So now removing two parallel removing the remaining two parallel lines, finished. Now here I got one more neat triangle. Now for this triangle also I am going to apply the basic proportionality theorem. So what it will become then? Lower one by upper one, BE by EC. BE by EC is equals to, same here also, upper one by lower one, BD by DA. BD by DA. Now if we observe these two equations, first one and second one, in these two we can get something common, that is BD by DA. So obviously these left side parts are also equal to each other, that is BF by FE equals to BE by EC, hence proved. Next question. A person 1.65 meter tall casts 1.8 meter shadow. So one person, his height is 1.65 meters and he is casting a shadow of 1.8 meters. We will get one right angle triangle. Next, at the same instance, a lamp post casts a shadow of 5.4 meters. Here one more lamp post is there. That lamp post shadow is of 5.4 meters. Then he is asking to find the height of the lamp post. So this height of the lamp post we need to find out. I am taking that as some h. Let us check these two figures. Now if you observe this clearly, this is 90 degrees and this is 90 degrees, because those two are vertical figures. Next, these two are at infinite distance from the sun. So the sun rays will touch these objects with the same angle. If you take these two angles also, if you take these two angles also, those two will be same every time. So now, if two angles are equal to each other, then obviously the third angle is also equal to each other. So according to this concept, all the three corresponding angles are same in both these triangles. So we can conclude that these two triangles are similar triangles. So if those two triangles are similar figures means, then we can say that the corresponding sides ratio is same. So according to that concept, left side by left side, 1.65 by h equals to base by base, that is 1.8 divided by 5.4. So let us simplify this further now. 1.8 1s, 1.8 3s. If you do cross multiplication, 1.65 into 3 equals to h into 1. H into 1 is h only simply. So now what is the value of 1.65 into 3? 3 5 is 15, 5, 1 carry, 3 6 is 18, 9, 1 carry here, 3 1 is 3. So 4.95, that is equals to h into 1 h. So height of that lamp post is 4.95 meters. Next, we have a triangle ABC where this CD line is a perpendicular line. CD is perpendicular line. Then he is asking to show that PC equals to AB. So what is the logic based on this one exactly? That's a very simple logic. So for that, observe this figure clearly now. We have ABC right angle triangle, right? So for that ABC right angle triangle, I am going to find out the area of triangle ABC. Area of any triangle is half into base into height, half into this BC is the base, that base is given as small a, into height. This AC will become height and that AC is given with a small b. So half into AB into B, that is nothing but half AB. Next, again I am going to find the area of the same triangle ABC. Area of triangle ABC is equals to half into base into height. Now instead of taking this BC as the base, I am changing the base now completely. Previously I took BC as the base, now I am taking this AB as the base. So AB means alphabet C, half into alphabet C into, then what will be the height? If I am changing the base of the triangle, then definitely the height also figure will be changing. So then this CD will become the height, that is nothing but alphabet P. So alphabet P, half into C into P, half CP. Now whether you are taking the base as BC or else whether you are taking the base as AB, always the area of the figure remains the same. So it means this area and this area both are equal to each other, that is half AB equals to half CP. Half AB equals to half CP. Left side half, right side half, both will get cancelled to each other. So remains with AB equals to CP. This is the first answer. Now from this only I will do one more small simplification, that is bringing P to the left side. Then we will remains with AB divided by P equals to C. This I will use for the solving of second question. Then the second question is asking to show that 1 by p square is equals to 1 by a square plus 1 by b square. Now, if we observe this right angle triangle clearly, right angle triangle means immediately we will go with the Pythagoras theorem, right? So, if we apply the Pythagoras theorem for this also, hypotenuse square is equals to first side square plus second side square. Here hypotenuse is c square equals to a square plus b square. So, for this right angle triangle, let us apply Pythagoras theorem, that is c square equals to a square plus b square. C square equals to a square plus b square. Now here c value we got as ab divided by p. So c square equals to ab by p whole square, that is equals to a square plus b square. Now here ab by p whole square is nothing but square is applicable for the numerator as well as for the denominator. So if we simplify this further, ab square by p square is equals to a square plus b square. This can also be written as 1 by 1. Doing cross multiplication, sorry, a square b square into 1 a square b square is equals to a square plus b square into p square, a square plus b square into p square. Now I am taking this p square to the left side and a square b square to the right side. So what it will become then? This p square I am taking to another side, so it will become 1 by p square, that is equals to a square plus b square by a square b square. Left side I'll keep as it is, equals to right side I am changing it as a square plus b sorry, separate I'll write a square by a square b square plus b square by a square b square. Here a square cancel, b square cancel, then finally we remains with 1 by p square is equals to 1 by b square plus 1 by a square. Coming to the questions related to tangents and secants. OA is radius of the circle and AP is tangent of the circle. Then we need to find this OP measurement, that is a point P which is outside of the circle, that distance from the center of the circle we need to find out. So here if you observe this clearly, wherever the radius is touching the tangent, this is the radius and this is the tangent, right? So these two are touching with each other at this point, then that will be 90 degrees always. So this is 90 degrees means the triangle is right angle triangle without doubt. So here this is 90 degrees. So opposite to this 90 degrees always it is hypotenuse. It means this OP is hypotenuse. I am taking it as some constant x. Now if it is right angle triangle means easily we can apply Pythagoras theorem. So let us apply that. Hypotenuse square is equals to 3 square plus 4 square. 3 square 9 plus 4 square 16. 9 plus 16 25. X square is 25. Then what will be the x value? It is 5 units. Next in this one, this is one of the very important questions in this. Based on this question only, one more question also will be there again in the exercise. This is example problem actually. In a quadrilateral ABCD, we have one circle also, and where the circle is touching the quadrilateral, the points are given as P, Q, R and S. Then he is asking to prove that AB plus CD equals to AD plus BC. This prove that statement also we need to remember, which is helpful for the part B especially. AB plus CD. This is AB line and this is CD line. These two lines, if you do addition, we will get AD plus BC. That is these two lines, AD plus BC line. That's it. That if you remember means it will be helpful for the part B. Okay, let us check then how to simplify this. So before going to simplify this, you need to have a small basic logic in your mind. That is, AB and CD both are towards the left side of the equal symbol. Just keep that in mind. AB and CD both are towards the left side of the equal symbol. So now this is AB, right? So that is AB. AB is nothing but from here to here as well as here to here, that is AP plus BP. So AP plus BP. Then CD is there, right? So CD is nothing but from here to here total. So that is CR as well as DR. So CR plus DR. Now from the next step, whatever you are going to write, this AP, BP, CR, DR, these all four should be towards the left side of the equal symbol. Just keep that in mind. In case if you write these in the right side of the equal symbol instead of left, you will go wrong. So be careful with this one. AP, BP, CR, DR. Just this is a rough part only. You should not write this in the answer sheet because that will come in the final step. Okay, now let us check the concept of this one. Okay, this is point A, which is outside of the circle. So from this point A, this AS will become tangent and AP will become another tangent. From the outside of the circle, always the lengths or the measurements of the tangents are equal to each other. So AS measurement and AP measurement both are equal to each other. So AS equals to AP. AS equals to AP. But according to my logic, AP should be towards the left side, right? Simply change this one. AP equals to AS. That's it. Next point we will go with. Here, point B. Point B is again outside of the circle. So then BQ will become tangent, BP will become tangent. So these two measurements are equal to each other. So BP is equals to BQ. BP equals to BQ. BP should be towards the left side only, so BQ is left side only, no problem. Next point. If we take point C, point C is again outside of the circle, so CR is one tangent and CQ is another tangent, so CR is equals to CQ. CR equals to CQ. Next, D is another point which is outside of the circle. So DR and DS both are tangents again. So DS is equals to DR. DS is equals to DR. Now observe again clearly. CR should be left side. Okay, left side only. DR should be left side. But DS is left side. So just interchange here and there. DR is equals to DS. DR equals to DS. Now all these four equations we need to do addition. Left side only we need to do addition. Right side only we need to do addition. So what are left side? AP plus BP plus CR plus DR equals to, right? Add all the right side parts now. That is AS plus BQ plus CQ plus DS. Now if we observe these two, AP plus BP, this is AP and this is BP. AP plus BP is nothing but AB plus CR plus DR. From here to here it is CR and from here to here it is DR. CR plus DR is nothing but CD. So AB plus CD equals to, next doing addition of the right side parts. AS and DS. This is AS and this is DS. AS and DS is nothing but total AD line segment. AD plus next one is BQ and CQ. So this is BQ and this is CQ. That is nothing but total line segment BC. So BC. Hence proved AB plus CD is equals to AD plus BC. Now as I said earlier only, this is just a rough work. I am removing it completely. Finished. Now here why I am saying that write left side part to the left side only, right side one to the right side only, because while doing the addition in this step, if you are doing addition, for example this AS you wrote this side, that AS won't match with anything else. That is the reason I am saying that write the left side part to the left side only, right side numbers to the right side only, then immediately you will get the correct answer. Next, in a circle we have one quadrilateral. So he's asking to find out the angle there. Let us check once what is the logic he is using. This OP is a radius and this AP is a tangent. Where the radius is touching the tangent, it will make 90 degrees. OQ is another radius, AQ is another tangent. OQ, AQ, where those two are touching with each other, it will make 90 degrees, because where the radius is touching the tangent, it makes 90 degrees. Then this is already given as 110 degrees. Then he is asking to find out this angle now. So that angle, let us check. Now what is this total figure? OP one side, AP second side, AQ third side, OQ fourth side. Total 4 sides are there, means it is a quadrilateral. Sum of all the angles in a quadrilateral is 360 degrees. So that is nothing but angle P plus angle O plus angle Q plus angle A equals to 360 degrees. Angle P is 90 degrees plus angle O 110 degrees plus angle Q 90 degrees plus angle A unknown number is equals to 360 degrees. 90 plus 90, 180 plus 110, 290 plus angle A is equals to 360 degrees. Now take this 290 degrees to the another side, then it becomes minus. So angle A is equals to 360 minus 290. Then finally angle A is equals to 70 degrees. Next, find the lateral surface area or LSA of a cube if edge is 4 centimeter. So what is the formula for LSA of a cube? That is 4a square. So which is equals to 4 into a square. Edge of the cube, a value is given as 4. So 4 square. So this is can be written as 4 into 4 square is 4 into 4. So now 4 into 4 into 4. 4 4 is 16. 16 4 is 64. And units are centimeter square. In this total chapter mensuration, the units are must and should. Don't forget these units ever. Next, if TSA, total surface area of a cube, is given as 96 centimeter square, then find the edge of cube. So what is the formula for TSA of a cube? TSA of cube is equals to 6a square. So this 6a square value is given as 96. 6 ones are 6, 16s are. So a square is equals to 16. Then a value will be 4 centimeters. Then edge of the cube is 4 centimeters. Next, find volume of a cube if A, that is edge of the cube, is 3 centimeters. Then he is asking to find out volume of a cube. What is the formula for volume of a cube? A cube. So A cube is 3 cube. So 3 cube is nothing but 3 into 3 into 3. 3 3s are 9, 9 3s are 27. 27 centimeter cube. Next, if volume of a cube is 729 centimeter cube, then find the edge of the cube. So volume of a cube formula is equals to a cube, right? Then this a cube is given as 729. So a cube is equals to which number cube is 729? That is 9 cube. So edge of the cube will be 9 centimeters. Next, find the volume of a sphere if radius is given as 7 centimeters. So what is the formula for volume of a sphere? Volume of sphere equals to 4 by 3 pi r cube. 4 by 3 into pi value 22 by 7 into r cube, that is radius is 7 centimeters, right? So 7 into 7 into 7. This 7 and this 7 cancel. And here no else cancellations. Then we remains with 4 by 3 into 22 into 7 into 7. So all the numerators we need to multiply, not to have any confusion. Just write this as 22 by 1, 7 by 1, 7 by 1. Now we need to multiply this 4 into 22. 88. 88 into 7. 616. 616 into 7. 4300. 4312 by 3 1s are 3, 3 1s are 3, 3 1s are 3. So 4312 by 3. We are finding volume. So then units will become centimeter cube. Next, if spheres of radius 6 centimeter, 8 centimeter, 10 centimeter are melted and made into a big sphere, then find the radius of that big sphere. So what he is saying is, one sphere is there with 6 centimeter radius and one more sphere with 8 centimeter radius and one more third sphere with 10 centimeter radius. These three spheres we are melting and we are creating one bigger sphere. For that bigger sphere, we need to find out the radius. So now whenever we are melting one and forming another, means we need to find volume every time. So volume of the beginning is equals to volume of the ending. So that is nothing but volume of these three spheres is equals to volume of this larger sphere. So let us find out the volume of the spheres first of all. So we have a formula for volume of the spheres, right? So that is 4 by 3 pi r cube. 4 by 3 pi r cube. That is volume of a sphere. But in this case, 1, 2, 3, total 3 spheres are there with a different radius. So that is the reason I am changing the formula a little bit. That is 4 by 3 pi r cube. I am writing it as pi r1 cube. This is the volume of the first sphere, plus 4 by 3 pi r2 cube, second sphere volume, plus 4 by 3 pi r3 cube, third volume sphere. That is equals to 4 by 3 pi capital R cube, resulting sphere. Now this left side part, if we observe clearly, 4 by 3 pi, 4 by 3 pi, 4 by 3 pi common, that is I am taking that 4 by 3 common now. 4 by 3 pi common. Then we remains with r1 cube plus r2 cube plus r3 cube. That is equals to this right side part as it is 4 by 3 pi r cube. Left side 4 by 3, right side 4 by 3 cancel, left side pi, right side pi cancel. Then finally we remains with r1 cube plus r2 cube plus r3 cube is equals to capital R cube. Now in the question only they gave clearly that radius of the spheres are 6, 8 and 10 centimeters. So this is 6 cube plus this is 8 cube plus this is 10 cube. That is equals to capital R cube. 6 cube 216 plus 8 cube 512 plus 10 cube 1000 is equals to R cube. 1000 plus 512 plus 216, 2 as it is. So 1728. Capital R cube is equals to 1728. So it means which number cube is 1728? That is 12. So capital R is equals to 12 centimeters. Radius of the resulting sphere is 12 centimeter. Next, this is one of the very, very important questions again. That is, a sphere, cylinder and cone are of same radius, same height. Then find the ratio of their curved surface areas. Okay, first of all, we have a sphere, then a cylinder, and then cone. In the question, he clearly mentioned that all are having same radius and same height. Okay, now let us take the sphere first. From the center, this will become the radius of the sphere, right? Then this will become diameter of the sphere. Now the same diameter, if we observe that diameter is touching this end of the sphere and this end of the sphere, then that diameter is nothing but height of the sphere. So height of the sphere is nothing but diameter. So diameter is nothing but 2 times the radius. R is as usual R only, right? Now observe, he is asking to find out the ratio of their curved surface areas, right? So curved surface area of the cylinder formula is 2 pi r h. 2 we know, pi we know, radius we know, height we know. So no problem with this figure. Next, coming to the second figure, that is, oh sorry, I wrote 2 pi r h is a cylinder, right? Sorry. Curved surface area. Actually for sphere, curved surface area, total surface area both are same, that is 4 pi r square. 4 pi r square. Okay, 4 is there, pi is there, r is there, so no problem with this. Now moving towards the curved surface area. So for the curved surface area of the cylinder is 2 pi r h, right? So this is radius r, and this will become the height of the cylinder, right? In the figure only clearly said that these three figures are having the same height. So if sphere height is 2r means then cylinder height also 2r only, right? So now this figure formula is 2 pi r h, right? 2 we know, pi we know, radius we know, height we know. Finish, no problem with this also. Next, coming to this, in this also I'll write clearly. Height of the cylinder is 2 times the radius, and radius is r only as usual. Now coming to this cone. Cone curved surface area is pi rl. This is radius, no problem, and this height is 2 times the radius, that is also no problem. Here pi okay, r okay. Then what about this L value? L is nothing but slant height. So let us first of all find out the slant height of the cone. So for that I am taking the cone separately again. This is height of the cone, that is 2 times the radius. This is radius of the cone, that is r. Then the slant height we need to find out now. Again this is right angle triangle. So let us apply Pythagoras theorem for this. So L square is equals to 2r whole square plus r square. 2r whole square, 4r square plus r square. 4r square plus r square, that is 5r square. So L square value is 5r square. Then what about the L value? Under root 5r. So the slant height of the cone is root 5r. So L equals to root 5r, and radius is as usual radius only. Now he is asking to find out the ratio of these curved surface areas, right? So let us apply one by one now. First, curved surface area of the sphere 4 pi r square is to curved surface area of the cylinder 2 pi r h is to curved surface area of the cone pi rl. Now this 4 pi r square I am writing it as 4 pi r square I am writing it as r into 2 pi r h is to pi r l. Pi will get cancelled. Radius will get cancelled. Here he clearly mentioned in the question that all the three figures are having the same radii. That is the only reason I am cancelling this r, all the r here. Otherwise you should not touch those. 4r is to 2h is to L. Okay, now 4r as it is to 2 into, what is the h nana here? H is nothing but height of the figure, right? That is 2 times the radius. For all the figures height is same only anyway, so any figure height you can write 2r is to slant height. Slant height is for cone, right? That is root 5r. So substitute here root 5 times r. Root 5r. So now if we observe here again r will get cancelled. Then finally we remains with 4 is to 2 to the 4 is to root 5. So the curved surface areas ratios of the figures sphere, cylinder and cone are 4 is to root 5. Next question. If sine theta equals to 6 by 10, then find the value of cos theta. Take one right angle triangle neatly. Don't touch this angle because this is always 90 degrees only. Either this angle or else this angle you can take, it's up to you. So I am taking this angle now. So this just keep it as theta. Now in the question he gave that sine theta is equals to 6 by 10, right? So for this theta, this will become opposite. So this is opposite and this will become adjacent, and this will become hypotenuse. Now in the question he gave sine theta is equals to 6 by 10. So sine is nothing but opposite by hypotenuse, right? So this will become opposite and this will become hypotenuse. Opposite is 6, hypotenuse is 10. So opposite is 6 and hypotenuse is 10. Then he is asking to find out the cos theta value. So let us check how to find out that cos theta now. This is right angle triangle. So immediately right angle triangle means we need to apply Pythagoras theorem. Let us apply that one. Hypotenuse square is equals to first side square plus second side square. Here second side is don't know, right? So I am taking it as some constant x square. 10 square 100 is equals to 6 square 36 plus x square. I need to find out the x value, so take 36 to the left side, then we get 100 minus 36 is equals to x square. So x square is equals to 100 minus 36 is 64. X square is 64. Then what will be the x value? It is 8 at the 64, 8 units. So this adjacent will become 8. Okay, now he is asking to find out the cos theta value. Then cos theta is nothing but adjacent by hypotenuse. So here what is the adjacent value? 8 and hypotenuse is 10. 8 divided by 10. Next question. If phi sin theta equals to 4, then find the value of tan theta. Now here phi sin theta equals to 4 is given. Take this phi to the right side, then we get sin theta is equals to 4 by 5. Okay, immediately take one right angle triangle. Don't touch this one because it is always 90 degrees. Take this angle or else another angle as theta, your wish. I am taking this as theta now. So if this is theta, then this will become opposite and this will become hypotenuse, and this finally will become adjacent. So now in the question he gave sin theta is equals to 4 by 5. So sin theta is nothing but opposite by hypotenuse. So then opposite is 4 and hypotenuse is 5. So this will be 4 and this will be 5. Now we need to find out the third side. So let us check how to find out that one. Same, I am taking this as x again. So let us apply the Pythagoras theorem again. Phi square is equals to 4 square plus x square. Phi square 25 equals to 4 square 16 plus x square. We need to find out the x value, so take 16 to this slide. So 25 minus 16 is equals to x square. 25 minus 16, 9. 9 is equals to x square. X square is 9. Then what will be the x value? It is 3. So this adjacent value will be 3. Now from the figure he is asking to find out the value of tan theta. So what exactly tan theta is? Opposite by adjacent. So from the figure let us check opposite and adjacent values. Opposite is 4 and adjacent is 3. So 4 divided by 3 is our answer. Next one. If cos theta equals to 3 by 5, then find the value of sin theta plus cos theta. Immediately take one right angle triangle. Here I am taking it as theta. He gave cos theta equals to 3 by 5. So for this theta, this will become opposite and this will become adjacent and this becomes hypotenuse. So now cos theta value is given as 3 by 5. So cos is nothing but adjacent by hypotenuse. So adjacent is 3, hypotenuse is 5. So two measurements are there. Here unknown measurement opposite side is there, that we need to find out. So let us apply the Pythagoras theorem as usual. Phi square is equals to 3 square plus x square. Phi square 25 equals to 3 square 9 plus x square. Take 9 to this left side. So 25 minus 9 is equals to x square. Then x square is equals to 25 minus 9, 16. X square is 16. Then x is equals to 4. That is nothing but this opposite side, we got it as 4. Then he is asking to find out the value of sin theta plus cos theta, right? So sin theta plus cos theta. Sin theta opposite by hypotenuse plus cos theta adjacent by hypotenuse. From this figure, let us check what are those values. First, opposite by hypotenuse. Opposite is 4 and hypotenuse is 5. So 4 by 5 plus adjacent by hypotenuse. Adjacent is 3 and hypotenuse is 5. So 3 by 5. Here both the denominators are same. So if denominators are same means we can add the numerator. So 4 plus 3, 7 divided by 5. Next question. If tan theta equals to 3 by 4, then find the value of sin theta plus cos theta whole divided by cos theta minus sin theta. Immediately draw right angle triangle. I am taking this as theta. Then this will become opposite and this will become adjacent. This becomes hypotenuse. He gave tan theta value. So tan theta is nothing but opposite divided by adjacent. So here opposite is given as 3 units and adjacent is given as 4 units. Now by using these two sides, first of all let us find out the hypotenuse. Hypotenuse square is equals to 3 square plus 4 square. 3 square 9 plus 4 says 16. 9 plus 16 25. Hypotenuse square is 25. Then what will be the hypotenuse value? It is 5 because 5 has a 25. So now 5. All the three values we got. Let us find out the value of then sin theta plus cos theta by sin theta plus cos theta divided by cos theta minus sin theta. So we need to find out this. First, what is sin theta value? Sin opposite by hypotenuse 3 by 5. 3 by 5 plus cos theta adjacent by hypotenuse 4 by 5. 4 by 5 whole divided by cos theta 4 by 5 minus sin theta 3 by 5. If we observe this upper part, both the denominators are same. So add the numerators. 3 plus 4, 7 by 5 whole divided by lower part. If we observe again both the denominators are same. So subtract the numerators. 4 minus 3, 1 by 5. 5, 5 both will get cancelled. Then finally we remains with 7. Next one. Find the value of sin 45 plus sin 30. So in this case, it is compulsory to remind all the values of the trigonometric ratios of 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees of all the 6 ratios. Sin 45, 1 by root 2 plus sin 30, 1 by 2. So now I am going to do cross multiplication for this. Root 2 into 2, 2 root 2. 1 into 2, 2 plus root 2 into 1, root 2. So the value is 2 plus root 2 by 2 root 2. But we don't want any irrational number in the denominator. So that is the reason to remove this root 2, we will multiply and divide with root 2 again. So that in the denominator, that irrational number will become a rational number. Let us check how it will become then. 2 into root 2, 2 root 2 plus root 2 into root 2, 2 divided by down 2 is there as it is into root 2 into root 2, 2. So now finally we remains with 2 root 2 plus 2 divided by 2 plus 2, 4. Now from the numerator we can take out 2 common. So if I take out 2 common, then we remains with root 2 plus 1 divided by 4 as usual. 2 1s are 2 2s are. So finally our answer is root 2 plus 1 divided by 2. Next, this is one of the very important questions. Express sin theta in terms of tan theta. After the word in terms, which trigonometric ratio will be there? Take that trigonometric ratio as x by 1. Tan theta, I am writing it as x by 1. So tan theta x by 1 is there means immediately we know our work. This I am taking as theta. So tan theta is nothing but opposite divided by adjacent. So this is opposite and this is hypotenuse, this is adjacent, right? So tan theta is given as x by 1, then tan is nothing but opposite by adjacent. So this is opposite and this is adjacent. So opposite will be x and adjacent will be 1. Now by using the Pythagoras theorem, we need to find out the hypotenuse. So let us check that one. hypotenuse square is equals to first side square plus second side square. So that is nothing but x square plus 1. That is hypotenuse square. Then what will be the hypotenuse? Under root x square plus 1. So hypotenuse we got as under root x square plus 1. Then which value he is asking now? In the question he is asking to find out the sine theta value, right? So let us write the sine theta value. Sine theta is equals to opposite divided by hypotenuse. So what is opposite in this figure? X by under root hypotenuse is under root x square plus 1. Under root x square plus 1. But in the solution at the first step we took tan theta is nothing but x. So here this x sorry, I'll replace with a tan theta. So tan theta whole divided by under root tan square theta plus 1. This is expressing sine theta in terms of tan theta. Next, if sine of a plus b equals to 1 and cos of a minus b equals to root 3 by 2, then find the values of a and b. Observe the first equation, sine of a plus b equals to 1. In sine, which angle is equals to 1? That is 90 degrees. So a plus b value is equals to 90 degrees. Coming to the second equation, in cos, which angle is root 3 by 2? That is 30 degrees, right? So a minus b is equals to 30 degrees. Now by solving these two equations, we need to find out the a as well as b values. Sorry. These two equations I am doing addition. A plus a 2a plus b minus b cancel equals to 90 plus 30 120. Then a value will become 120 divided by 2, that is equals to 60 degrees. A value is 60 degrees. This a value we can substitute either in the first equation or else in the second equation, then we will get the b value. I am taking the first equation, that is a plus b is equals to 90 degrees. This a I am replacing with 60 plus b as usual equals to 90. Take 60 to the right side, then b equals to 90 minus 60. B value is 30 degrees and here a value we got as 60 degrees. Sorry. Okay, coming to the next one. Is it correct to say that sine of a plus b equals to sine a plus sine b? In the place of a and b, you take any number. In the place of a, I am taking 30 degrees. And in the place of b, I am taking 60 degrees. Let us substitute in this now. First, I am taking LHS. That is sine of a plus b. Sine of a value is 30 degrees plus b value is 60 degrees. Sine 30 plus 60, 90. What is the value of sine 90? 1. Now RHS value. Sine a plus sine b. Sine a value 30 plus sine b value 60. Sine 30 1 by 2 plus sine 60 root 3 by 2. Here both the denominators are same, so we can easily add the numerators. 1 plus root 3 by 2. Left side answer we got as 1 and right side answer we got as 1 plus root 3 by 2. Both are completely not at all equal. So LHS is not equals to RHS. So we can say that it is not correct to say that sine of a plus b is equals to sine a plus sine b. So whenever we are taking a and b values in this question, you should be very careful with that. For example, in this case, if I take a value as 0 and b value as 30, then in this case LHS, RHS both will become equal. So in this kind of cases you need to be very very careful. So don't take 0, then take another numbers only. Next question. Here we have a triangle, some ABC. AB measurement is given as 4 units and AC is given as 8 units. Then he is asking to find out this theta value. Now observe this clearly. For this theta, this 4 will become opposite side, and for this theta, this 8 will become hypotenuse. Opposite and hypotenuse is there means it comes under the sine theta ratio. So sine theta is equals to opposite divided by hypotenuse. Sine theta equals to, what is the opposite here? 4 and hypotenuse is 8. So sine theta is equals to 4 divided by 8. That is 4 ones are 4 twos are. So sine theta is equals to 1 by 2. In sine, which angle is 1 by 2? 30 degrees. So theta value is equals to 30 degrees. Next, this kind of questions are very very important, especially in the part B. Writing in ascending order or else descending order, or else sometimes they will give two numbers and they will ask you to which one is bigger or which one is smaller. So how to find out these one? Sine 30 value we know very well, 1 by 2. Sine 70 we don't know, sine 59 we don't know, sine 18 we don't know. Then how to write those in ascending order or descending order? Just kind of total questions will be based on trigonometric ratio table. 0 degrees, 30 degrees, 45 degrees, and 60 degrees, 90 degrees, right? Now sine value, if we take sine 0, 0, sine 30, 1 by 2, and sine 90, 1. Sine 45 is 1 by root 2, sine 60 is root 3 by 2, but this 1 by root 2, root 3 by 2 is there means that value, so little difficult to find out and check whether they are ascending or descending also. So that's why the reason I'm completely removing that one, not to have any confusion at all. Now observe this clearly. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, here the angles are increasing, correct? Then what is happening to the value? Sine 0 is 0, sine 30 is 1 by 2, 1 by 2 is nothing but 0.5, and sine 90 is 1. So 0, then 0.5, then something till 1. Here the values are also increasing. In the sine ratio, if we observe clearly, as the angle is increasing, the value is also increasing. So lesser angle means lesser value, more angle means more value. Now we got some logic here, we can find it out easily. Now check it once. In this total, sine 18 is smaller angle, so sine 18 value will be small. Sine 18, then comes under sine 30, then comes under sine 59, then comes under sine 70. That's it. This is the ascending order. If we check the same question for cos theta, in the cos theta, as the angle is increasing, the value will decrease. So that will should be, keep it in mind. Next question. Prove that under root 1 plus cos theta divided by 1 minus cos theta is equals to cosec theta plus cot theta. So whenever you will be having a square root symbol like this, the same process you need to continue, that is rationalizing the denominator. Under root 1 plus cos theta divided by 1 minus cos theta into, here the denominator is 1 minus cos theta, right? So you do with 1 plus cos theta, just changing the symbol. In the denominator, if 1 plus cos theta is there means you need to go with the 1 minus cos theta. Under root 1 plus cos theta into 1 plus cos theta, 1 plus cos theta whole square by 1 minus cos theta into 1 plus cos theta, 1 square minus cos square theta, that is a plus b into a minus b formula, that is equals to under root 1 plus cos theta whole square by 1 square is 1, 1 minus cos square theta, sin square theta. Now if we observe this clearly, for the numerator we have a square, for the denominator also we have a square. So that can be written as completely 1 plus cos theta by sin theta whole square. Then this square root and square both will get cancelled. Then finally we remains with 1 plus cos theta by sin theta. Then this can be written as, if we separate it, 1 by sin theta plus cos theta by sin theta. 1 by sin theta cosec theta plus cos theta by sin theta cot theta, hence proved. Next question. Prove that sin A plus cosec A whole square plus cos A plus sec A whole square is equals to 7 plus tan square A plus cot square A. Now left side part, if you observe clearly, sin A plus cosec A whole square, it is in the form of A plus B whole square. So A plus B whole square equals to A square plus B square plus 2AB. Then sin A plus cosec A whole square will become sin square A plus cosec square A plus 2 sin A cosec A plus second term cos A plus secant A whole square. Cos A plus sec A whole square also is in the form of A plus B whole square. So A plus B whole square equals to A square plus B square plus 2AB. Then cos A plus secant A whole square can be written as cos square A plus secant square A plus 2 cos A sec A. Now let us simplify this. Sin square A plus cos square A, it is one of the identities, that is equals to 1. 1 plus this cosec square A sec square A, I am writing as it is. Cosec square A plus sec square A plus this one 2 into sin A as it is into this cosec A, I am writing it as 1 by sin A because cosec and sin both are reciprocals to each other. Then plus again this term 2 as it is into cos A as it is into this secant A, I am writing it as 1 by cos A because cos and secant both are reciprocals to each other. So now if we observe this sin A will cancel, cos A both will get cancelled. So finally we remains with here 2, here 2, here 1. 2 plus 1, 5 plus cosec square A plus sec square A. So we have three identities completely, right? Sin square theta plus cos square theta equals to 1. Secant square theta minus tan square theta equals to 1. Cosec square theta minus cot square theta equals to 1. So from those three identities, let us check which one is helpful here. 5 I am writing as it is plus cosec square can be written as 1 plus cot square plus secant square 1 plus tan square. 5 plus 1 total 7 plus cot square A plus tan square A, hence proved. Okay, coming to the one of the very important questions, especially for the last section, that is, if cosec theta plus cot theta equals to k, then prove that cos theta equals to k square minus 1 divided by k square plus 1. The given question is cosec theta plus cot theta equals to k. This is one very important for us now. Cosec theta plus cot theta equals to k. Related to cosecant and cot, or else cosec and cot, we have one identity, that is cosec square theta minus cot square theta equals to 1. So cosec square theta minus cot square theta equals to 1 is one of the identities. Now this identity is in the form of a square minus b square. A square minus b square is equals to a plus b into a minus b. So the same way, this cosec square theta minus cot square theta can also be written as cosec theta plus cot theta into cosec theta minus cot theta equals to 1 as usual. Now this cosec theta plus cot theta is nothing but k. So this cosec theta plus cot theta I will replace with k into cosec theta minus cot theta is equals to 1. Taking k to the right side, we remains with cosec theta minus cot theta equals to 1 by k. Taking this as equation number 2. whatever they gave in the question, that I am taking as equation number 1. Adding these two equations. Cosec theta plus cot theta equals to k. Cosec theta minus cot theta equals to 1 by k. Plus cot theta minus cot theta cancel. Then we remains with cosec theta plus cosec theta 2 times cosec theta is equals to k plus 1 by k. So if we simplify this, 2 cosec theta equals to k into k square plus 1 by k. Not to confuse, this is just cross multiplication only. Taking 2 also to the right side now. Cosec theta equals to k square plus 1 by 2k. Now cosec theta value is there, so immediately drawing the right angle triangle. This I am taking as theta. So cosec is nothing but hypotenuse by opposite, right? So this is k square plus 1 and this will become 2k. Now by using the Pythagoras theorem, we need to find out the third side. Then the third side will be k square minus 1. Now in the question, he is asking to find the cos theta value. So cos theta is equals to adjacent by hypotenuse. So in this figure, adjacent is k square minus 1 by hypotenuse is k square plus 1. So hence proved.